From the Library of Congress in Washington, D.C.
Let's start our day-long program, and our opening celebrity and writer, a man of many parts, is Ben Bova. Ben is known as something of a triple threat, or as a figure in the field. That is, he's a novelist, and he'll be talking, I think, primarily about his writing today, but back in the 70s and 80s, he was the premier editor in science fiction, responsible for the Omni magazine for its initial years, and a man who has been a president of the National Space Society, commentator on radio and television, many times a winner of the Hugo Award, science fiction's ultimate accolade. And today he's going to talk to us a bit about himself, his writing, and more likely than not, his latest book, Faint Echoes, Distant Stars.
Well, thank you. And thank you, Michael, for that mercifully brief introduction. Those of you who have read my science fiction know that I try to write novels that are set in reality. I write about real people as they actually are. They may be in strange settings. They may be exploring Mars or chasing critters in the oceans of Jupiter. But everything I write is based on what we understand today of the way the universe really works. One of the most fascinating questions for all of us, I think, is, are we alone in the universe? Is this the only speck of rock in the whole universe where life exists? Or is life widespread? Is life plentiful in the universe? Well, when I run across questions like that, my first instinct is to write a book about it, a nonfiction book, because this forces me to learn more about the subject. And in the past 10 years, a new discipline has arisen in science. It's called astrobiology, and it is devoted to the study of life in the universe, the origin of life, the distribution of life in the universe, how widespread is life, and even life's fate. Where is life going? How does life interact with the rest of the universe? And this led me to write this book, Faint Echoes, Distant Stars. And although I've written many novels, like Mars and Jupiter and Venus and whatnot, occasionally I do write a nonfiction book, and Faint Echoes, Distant Stars is my most recent one. Until about 10, 12 years ago, just about everybody assumed that when you're looking for life, you look on the surface of a planet that's well lit by a star. After all, our life is here on the surface of a planet, and it depends on sunlight. All life on Earth depends on sunlight, right? Wrong. Beneath our feet, several miles down, there are bacterial forms of life that never see sunlight. They metabolize solid rock. There's more of them, pound for pound, than there is of us. Now, this idea was first proposed by the astronomer cosmologist Thomas Gold, who sadly died earlier this year. But I knew Tommy Gold, and he was a very innovative thinker. He often said, "I'd rather be wrong than dull." And Tommy came up with ideas that were very, very often regarded as absurd and turned out to be right. And years ago, he proposed that beneath the surface of the Earth, there's a deep, hot biosphere. Vast colonies of bacterial life that live without sunlight, that depend on chemical reactions powered by the heat of the Earth. And they can metabolize rock, sulfur, iron, things like that, and release methane. They need water. Every form of life we know requires water. But that doesn't necessarily mean life on other worlds will have the same requirement. What scientists have found in the past 10 years is that life is much more ubiquitous and much tougher than we ever imagined. There are microscopic creatures living in temperatures and under pressures that would kill us in an instant. Critters living inside of Old Faithful, in boiling water. Creatures living in the bottom of the ocean where there's no sunlight and 300-degree heated water comes up, big sulfur plumes that the oceanologists call black smokers. There's one that's my very favorite. It's a bacterium called radiodurans. It can survive thousands of times more radioactivity than you and I can. The biologists call it Conan the bacterium. It seems to be unconquerable. It's been found living in the radioactive wastewater of nuclear reactors. So life is very, very tough. And what we found with all of these different forms of life living in extreme environments, the biologists now lump them all together and say they are extremophiles. Creatures that live under environments that are too extreme for us to even think about surviving in. But the extremophiles may very well represent the earliest forms of life on this planet. Because when the Earth first formed, it wasn't like this. It was a molten ball of rock, pounded by constant infall of other rocks, meteors and comets. The surface was literally molten. There was no atmosphere. Gradually, the planet cooled, and the oldest rocks that geologists have found are between 3.5 and 4 billion years old, and those rocks bear traces of life. There are chemicals in those rocks that could only have been produced by living creatures. And that whole form of life was wiped out, totally extinguished, by a cataclysmic collision between the Earth and another object about the size of Mars, smashed into our planet and blew off a lot of the planet's crust. That crust eventually formed an orbit around the Earth, coalesced, and became our moon. So the origin of the moon wiped out life on Earth. It had to get started all over again. And it did. Obviously, we're here. The real question among astrobiologists today is how much of the life here on Earth is indigenous, and how much did it depend on materials and energy coming in from space? We know that in that bombardment of billions of years ago, there were lots of comets, and they brought lots of water. Of course, water also sweated out from the interior of the Earth. Water is the most common three-atom molecule in the universe. Wherever astronomers look, they see water. On frozen Mars, there is water. Jupiter, this enormous gas giant of a planet, has an ocean of water 10 times larger than the Earth. Very warm water, too. And in my novel, Jupiter, I started to think about what kind of creatures might live in that ocean. An ocean without any land. An ocean 10 times bigger than the Earth. An ocean on a planet that spins around every 10 hours. Terrific currents. And of course, with the freedom of imagination of a fiction writer, I put very large creatures in that ocean. Leviathans, creatures the size of cities, creatures that are very unlike anything on Earth. The moon, the creation of the moon wiped out life on Earth, and the moon's demise will wipe out life on Earth again. You know, the moon right now is gradually edging away from the Earth, but it will reach a limit and then begin approaching. And at some point, it will begin to break up. And when that happens, we'll have meteor showers like you've never thought of. And it will just pound the Earth's surface into rubble. So we have a couple of choices. We can just sit here and let it happen. I mean, this is going to happen in a few billion years, folks. We better get ready. Or we can leave the Earth or we can learn how to stop the moon from getting that close. And we do have a few billion years, so I'm sure we'll think of something. The Earth has never been in isolation. It has always interacted with the rest of space around us. And the processes that formed life on Earth are not all that exotic. If you give the same chemical ingredients and the same inputs of energy at the same temperature range, almost anywhere, you could get life forming again. Now, Mars is the most Earth-like planet we can see, and it's not terribly Earth-like. Mars is tilted on its axis, the same as Earth. We see that it has polar caps that melt in the summer and reform in the winter. It spins in just about 24 hours. A Martian day is a few minutes longer than our day. But there the similarities end. Mars is very dry and very cold. In midsummer day on the equator of Mars, the ground temperature might get up to about what it is here this morning. But at that very moment, the temperature at your nose would be 0, because Mars's air is so thin it doesn't carry any heat. There's no problem with a greenhouse effect on Mars. And that night, the temperature will go down to 100 below 0. So Mars is very cold, and yet we have some intriguing hints that life existed once on Mars and may exist there now. Meteorites have been blasted off the surface of Mars by giant impacts, wandered through space, and some of them have fallen to Earth. There are at least 13 meteorites that we know came from Mars. And we know it because inside these meteorites are little bubbles of trapped gases, and they're the same ratio of gases that we found in the Martian atmosphere when we sent landers down to Mars. These meteorites, when examined, a couple of them show structures inside of nanometer scale, billionth of a meter. And they look like bacteria, fossilized bacteria. Now, many scientists say this isn't so. Others say it looks as if it's real. And I suspect we won't know for sure until we get to Mars and do some digging. The first human expedition to Mars, and in fact in one of my novels about Mars, the expedition includes a Texas oil rigger and his equipment, because to find life on Mars, you have to go a couple of miles down. It's probably there, or at least it was there once. It may be fossils now. Now, if you look in toward the sun, the closest planet to us is Venus. And when you see Venus in our night sky, it looks beautiful. Just every culture has named that planet after its goddess of love and beauty. We call it Venus. But when you get close to Venus, you realize it isn't really all that beautiful. Venus is almost the same size as Earth, but it's very hot. It has a tremendous greenhouse effect. Venus is covered with clouds of sulfuric acid. That's what makes it shine so brightly. Makes it look beautiful. But it's not the stuff you want to live in. Venus's atmosphere is very, very thick, very dense. Down on the ground, the air is about as dense as seawater a mile below the surface. The temperature is hot enough to melt aluminum. At night, the ground of Venus glows because it's so hot. Could there be life there? Well, there's no water. It's too hot for water to exist except way up in the clouds. Some people have suggested that life might exist in those clouds where the water droplets are. After all, we have to realize that life is not constrained to the things that we know. There's plenty of energy on Venus, and in those clouds of Venus there is something that absorbs ultraviolet light. We don't know what it is. The scientists are not terribly poetic. They call it the great UV absorber. A science fiction writer would have called it glop or something. But what that UV absorber might be is a form of life living in the clouds of Venus, absorbing ultraviolet energy, using that energy to live on. We just don't know. In my novel Venus, I went a little farther than most people would. I postulated creatures living on the ground in Venus. 400 degrees or 800 degrees Fahrenheit. Creatures made of silicon. Now we have human beings who are partially made of silicon, or silicone actually. The silicone creatures on Venus have liquid sulfur for blood, and they're pretty nasty. That's a speculation. And in most of my novels, they're called science fiction, but I've always thought of them as historical novels that haven't happened yet. And I intend to live long enough to see if I'm right. Some of my novels have turned out to be history. I would like to see what's on Mars. I'd like to see if there are silicone creatures on Venus. I know there are silicone creatures in Los Angeles, but that's another story. We have now seen more than 100 planets circling other stars. We have seen the ingredients for life everywhere we look in the universe: water, carbon, and lots of energy. There is no reason why life should not be ubiquitous, just as normal a part of the universe as rocks and stars. But the interesting question is, what about intelligent life? Now, I know people who ask, is there intelligent life on Earth? Well, I think there really is. But for 50 years, radio astronomers have been searching the skies for signals of intelligent civilization. They're not looking for deliberately beamed signals at us. They're trying to pick up the "I love Lucy" of some other civilization, transmissions that have wafted through space. It's kind of sobering to think that maybe 50 light years from here, they are picking up "I love Lucy" and wondering if there's intelligent life on Earth. But for 50 years, we've been searching with better and better equipment and have found nothing, which has given many scientists a very pessimistic view. They feel probably life is abundant in the universe, but it's only microbial life. It's bacteria, germs. After all, bacteria are far more numerous here on Earth than we are. There's much more bacteria than any other form of life, and they are among the oldest forms of life. Bacteria have survived all kinds of catastrophes on Earth, and long after we're gone, the bacteria will still be here. So if bacteria is really the dominant form of life on Earth, why shouldn't it be the dominant form of life elsewhere? We sort of tacitly assume that if life gets started on a planet and you give them enough time, an intelligent species will arise. Well, that might be a false assumption. There might be no special reason for intelligence to arrive. Intelligence might just be a weird adaptation that one species took out of 4 billion years worth of species and evolution. So we think intelligence is the top of the ladder. It might just be an accident, a lucky accident for us. Certainly makes life interesting. Bacteria lead dull lives. They don't even have sex. On the other hand, they don't age. There may be bacteria alive and well today that are billions of years old. You can kill bacteria, but they never age. So the search for life and where life fits into the universe, how life affects the universe, is what astrobiology is all about. And if you pick up a copy of Faint Echoes, Distant Stars, you'll see discussions of this in language that I can understand, and therefore certainly you can understand. And I think I'd like to ask if you have any questions or comments. Thank you. Thank you. Once at a science fiction convention, I was introduced very fulsomely, and something got into me, and I came up and said, "Thank you very much for that wonderful introduction. That concludes my formal remarks. Are there any questions?" And for a solid hour, they asked questions. So I'm hoping you are just as inquisitive. Yes, sir.
Do you have any comment on the Spaceship One X Prize?
Do I have any comment on the Spaceship One X Prize, Burt Rutan's spacecraft that reached 100 kilometers altitude, in a suborbital flight twice inside of a week? And yeah, I have a comment. Where do I get a ticket? I think what we're seeing is, at long last, the beginning of a transition of space endeavors going from totally government operations to operations by private enterprise, operations that are out there to make a buck. And I think we're going to move much faster that way. Governments' space programs, like all government programs, are run for political reasons. In the 1960s, we developed the finest technology and the finest team that the world had ever seen and put Americans on the moon. And then we threw it away. We laid off most of those people. I had a friend in Boston who was driving a taxi cab. He said he was on a Nixon fellowship. And governments make decisions for political reasons, but private companies make decisions for profit. And if we can make profits out of taking tourists into space, if we can make profits out of building solar power satellites that will provide electricity to us cleanly and efficiently, if we can make profits out of mining the resources of the moon or the asteroid belt, all of which I've written about in fiction, it's going to happen, and it's going to happen much faster than any government program could do. Yes, sir. There are microphones somewhere if you want to use them.
They decided not to bring
Oh, okay. No, there are not microphones. I'm sorry. If you'll just stand up and holler. Yes. Yeah. All right, let me try to encapsulate your question. There are many biologists, prominently the late Stephen Jay Gould, who think that intelligence is sort of an accident, that there's no requirement for intelligence to arise. In fact, Gould wrote, if you went back, say, to the Cambrian period and started all over again, it's very unlikely that an intelligent species would arise. On the other hand, there are biologists and other thinkers who feel that intelligence is a natural outgrowth of life, that if you look at the development of mammals especially, it's toward constantly larger brain sizes. And if an ape didn't become intelligent as we did, perhaps a dolphin would have, or some other creature. I come firmly down on both sides of the issue. I think when you've only got one datum point, it's hard to draw a curve. We just don't have enough information. We know intelligence arose here. Intelligence seems to be very, very rare if the great silence from our radio telescopes means anything. We've been trying to get intelligence signals. None have been found. If intelligence is very, very rare, then perhaps intelligence is sort of accidental. But it's a happy accident for us, and we should make the most of it. If the universe is devoid of other intelligent creatures, this does give us an opportunity, perhaps even an obligation, to spread our life wherever we can. Somebody from this side. Yes, sir.
Yes, obviously you do a lot of research in a variety of scientific fields. Do you have any particular sources that are your favorites as far as inspiring your books?
Do I have any particular sources for the scientific research that I do for my books? I try to keep current with the AAAS journal Science and the British journal Nature. I subscribe to Scientific American, but I just sort of stash the issues away. It's sort of an ongoing encyclopedia. When I need an article on a certain subject, I look it up there. I find one of the best sources of quick information and very concise information is published right here in Washington. It's called Science News. It's a weekly newsletter. It's only about 6 or 8 pages long, but it'll give you a good overview of what's going on and direct you to sources that give you more detail. So those are some of mine. Of course, I started out as a newspaper reporter, but when the U.S. government announced it was going to try to launch an artificial satellite, I jumped to working for the company building the launching rocket. That was in 1956. So I've been involved in space technology 2 years longer than NASA. So I've got a lot of friends in the business, a few enemies too, but a lot of friends. And I pester them unmercifully. Oh.
When you were talking about intelligent life in space, how do you feel about the idea that there could be intelligent life, and that's what UFOs are?
How do I feel about the idea that there might be intelligent life and that's what UFOs are? I wish it were true. I don't see any real evidence of it. There are lots of stories. When I was running Omni magazine, we worked very hard to verify flying saucer stories, UFO stories, stories of alien encounters, and they always disappeared into smoke and mirrors. We had one fellow come into the office with a little sliver of metal, and he said, "This was scraped off the hull of a flying saucer. It's unlike any metal on Earth." Well, we spent hours convincing him to let us test the metal. And finally, we reached an agreement. We would send him and one of our editors up to MIT on a Friday so that they could spend the weekend in Boston. And we had a metallurgist at MIT test it. The metal turned out to be aluminum. Now, it might have come from the hull of a flying saucer. You know, aluminum makes very good material for aircraft or spacecraft, but it might have come from a frying pan, too. It's just not conclusive evidence. I wish there were as much evidence as I would expect to take into court to get out of a parking fine, but I just haven't seen it. Yes, sir.
When you're writing, you speak to basically kind of hard science writing. At what point do you try to decide between keeping the science factual and keeping the story interesting?
That's a very good question. In my fiction, I mix scientific fact with speculation. At what point do I throw the science out, or at least bend it? I feel that my rule of thumb is I'm free to invent anything as long as no one can prove it's wrong. You know, I can have my characters build an anti-gravity machine, but I wouldn't dare try to explain how it works because I don't know, and neither does anyone else. But the modern reader is willing to accept perhaps someday an anti-gravity device could be built. If I wrote a novel set here on Earth and said grass is purple, then I'd probably be in trouble. So I'll go along and try to make it as accurate as possible, but I don't feel bound by what we know today. I like Clarke's dictum, you know, to understand the possibilities of tomorrow, you've got to go beyond the here and now. Do I miss editing? Not at all. I became an editor thanks to the tobacco industry. The most powerful and most wonderful editor in the field of science fiction, in fact, the best editor I've ever seen anywhere, was John W. Campbell, Jr. He was the editor of the magazine now called Astounding from 1937 until he keeled over at the age of 61 with a fatal heart attack. John was a chain smoker. I got elected to be the next editor of Analog. And although I had a very successful career in the aerospace industry and I was a successful novelist, being drafted to edit Analog was like being drafted to run for president. You're terribly afraid you're going to screw it up, but you can't say no. So I had 7 years at Analog, and then Bob Guccione started Omni, and that was an even sillier story. I sort of got drafted into that too. But after 4 years of Omni, that was enough. Orson Welles always said, I'm a professional director and an amateur actor. I feel that I'm a professional author and an amateur editor. Now, I did okay editing, and I had a lot of fun, but writing is what I want to do. Yes, sir.
You mentioned Campbell. I'm looking at Gernsback and seeing how he was so instrumental in the invention of television. Can you draw an example of that in today's age?
Talking about John Campbell, and the gentleman referred to Hugo Gernsback, one of the very early pioneers in science fiction. Examples from today's age, inventions that have come true.
Like the whole thing with Farnsworth and Gernsback.
In the 1960s, I wrote a novel called The Dueling Machine. I didn't realize it at the time, but I had invented virtual reality. I wasn't smart enough to copyright it or patent it. Arthur Clarke invented the communication satellite, and he couldn't patent it or copyright it. So Arthur, being very clever, did a canned speech called How I Lost $1 Billion in My Spare Time. We have time for maybe 2 more questions. Haven't heard anything from that part of the field. No, you're just going to be quiet. Okay. Anybody else? Oh, there we are.
Inventions that you know of, let's say in the most recent 5 years, do you see anything else that's a very significant departure that's going to carry us off into the brave new world?
Yeah, I think superconductivity, which was actually discovered in 1910, but today we have relatively high temperature superconductors. Superconductor is an electrical conductor that has no resistance. So you build a superconducting magnet, charge it up, and it stays charged forever. Well, 10 to the 90th years, but then the calculations run out. The trouble is you have to keep them cold. The earliest superconductors, you had to use liquid helium, 4 degrees above absolute zero. Contemporary superconductors, you use liquid nitrogen, which is industrially available. And people are searching for room temperature superconductors. When we get a practical superconducting magnet, it will store as much energy in the same space as the gas tank in your automobile. And then we'll have a practical electrical car. In fact, that car will have 4 little superconducting motors in the hubs of the wheels, which not only gives you much better performance, but gives you extra trunk space where the engine used to be. I think that is going to be a big transformation because it will get us off the petroleum kick. And that's, I think, a very important thing for us to do. I'm running over time, I'm told, so thank you very much. You've been a great audience.
This has been a presentation of the Library of Congress. Visit us at loc.gov.